atoms if you have trouble finding them. Yep. So about 28.35. So does anyone want me to explain how you got this number? Just say yes if you need if you want an explanation. Yeah. Okay. So we want an okay. So the first step is to find the molar mass of copper sulfate. So how do we find this? We do 63.55. So we look at the number under the little number on the periodic table at the bottom part of the square on the periodic table, and then plus. So we need one sulfur. Okay, so we've handled there's one copper, so we've handled that. So now we need one sulfur, so plus 32.06, and then plus. So we have 4 oxygens. So we look at oxygen. So oxygen is 16. So 4 times 16. So this gets us. Let me see. Okay, 159. Fine. Okay. So now this is equivalent to AMU per 1 formula unit. So 1 unit. And then you can show that this is equal to 159.5 grams per mole. Okay? So far, does this make sense? So this is how many grams per mole of stuff we have. And then all we need to do is multiply this number by this. So we have 0.1776 mole times 159.5 grams per mole. So these cancel out, and that gives you 28.3 grams. Okay? So does that clear up the confusion? Okay, great. So balancing equations. So has anyone balanced a chemical equation before? So it can be kind of tedious, but you have to do it. So some general tips and tricks. So you should start with compounds that have more different atoms first. So for example, in this in this equation, so oxygen gas only has 1 type of atom, so we can ignore it for now. And then we should handle all of this stuff first, okay? So we start with the more complex molecules, and then we do the simple molecules and the elements last. And then at the end, you want to make sure that we have equal numbers of each element on both sides. Okay? So in this case, it all works out, so this is correct. And I want to point out that this is helpful when we're talking about moles, because what this tells us is that if we take 1 mole of methane plus 2 moles of oxygen, we will get 1 mole of CO2 and 2 moles of H2O. Okay? So, okay. So Let's do another problem. So let me think. Can someone balance this equation? So I'll give you a minute to do it. Okay, so how would we do this problem? So we start with the more complex molecules. So can someone tell me what the most complex one is? What do you think the most complex one is? So what do you think the most complex molecule here is? Great, yeah. So this one is probably the best place to start with because it has the most parts and we have these messy subscripts that we have to deal with. So let's just start with this one first. So let's just assume that we have one here. Okay? So now if we have, so now can someone tell me what I should put in front of these? What should I put there? Okay. And, right. So we have 2 phosphates and 3 irons, so we need 2 more phosphates and 3 more irons. So now, what should I put here? Right? And does this all work out? Is this correct? Great, so this is good. Let me think of another one. So C4, 10. Okay. So what do you think the most complicated one here is? So this is the combustion of butane, which is, so a lot of times if you go camping, you might use this to create a fire. So can someone tell me what the most complex molecule here is? Right? Okay, great. So let's start there. So let's just put a 1 here. So can someone tell me what we should put here? Now we can ignore oxygen for now. Because ignoring oxygen, what should we put there? And 5, right? you have to be careful. There's a 2 here. Okay, so far so good. So can someone tell me how many oxygens are on this side? How many total oxygen atoms do we have here? Is that right? Yep, so 13 oxygen. So then what should we put here? Well, we need 13 over 2, which is 6.5. However, your AP chemistry teacher might not like this, and he or she will probably want all of these coefficients to be integers. So all we have to do is multiply all of these by 2. Okay? And, okay. So a lot of this is a bit of trial and error, but yeah, that's life, I guess. So I'll give you 10 minutes to balance the following equations. And type the coefficients you get into the chat. It might be helpful to just label which problem you're doing when you post the solution. Just a suggestion. Oh, and another major point I forgot to mention is that you need to balance the number of atoms, but you also need to balance the charge. And in this case, that doesn't matter since none of these are charged, but in the future, it will be important. So. So Brian, can you check number 3? Um, okay. Kathy, you should probably, can you check number 3? Okay. So I think everyone kind of understands how this works, right? Because looking at the answers, they're basically mostly correct. So, oops. So unfortunately, we don't have much time left, so let's just try to get through the rest, and then if we don't get through it all, I'll prepare some handouts. So here's a problem example. So let's say we burn 3 moles of C3H8, so propane, in excess oxygen. So that means we have an unlimited amount of oxygen to work with. So can someone just so can you start working on this problem? And let me just do it then. So by the way, that means, okay. Yep, so that's, yep. So I think that's right. That's correct. So all we need to do is how many grams of oxygen are consumed. So, yep, correct, 480 grams of oxygen. So does anyone need me to go over this problem? Nope. Okay, great. So let's move on. So can we also do these problems? So this lesson doesn't really have, there's not too much content to learn. I just want to make sure everyone is very, very, very familiar with the calculations because these calculations are very important. Does anyone have any answers yet? Angela, can you, wait, did I type in a number wrong? I think I might have typed in a number wrong. Yep, so that's correct. So I must have typed in number wrong in my calculator somewhere. So yeah, you're fine. So can we move on to question 2? Try to question 2. Let me check to make sure I didn't make a mistake again. Yeah, can you check your work for, can you check your work, Jessica, please? Yep, 35% is correct. So, can someone do problem 2 though? Yep, that's correct. So how many grams of nitrogen are in 50 grams? So you just need to multiply that percentage by the weight, right? So does anyone, I'll put up the solutions to these problems. I'm here if you want to read them. Does anyone want me to go over these solutions really? They're a bit messy, so I apologize for that. But does everyone understand how we do these calculations? Like, does anyone want an explanation? Basically. If not, I think we can do the last topic and then I will just have you do the practice problems. So, okay, this is the final topic. This one's maybe a bit difficult. So far we've only been considering one reactant and we assumed that the other reactant is present in excess, which makes the math easy. However, sometimes we have a limited amount of reactants, and we have to consider how much product will be formed given the reactant we have. So how do we do this? Well, we determine how much product can we make from each reactant, and then we pick the smaller choice. So for example, so let's say we have a fruit punch recipe. So we need, for 3 cups of fruit punch, we need 1 cup of rum and 2 cups of fruit juice. So how much fruit juice can we make using 10 cups of rum and 10 cups of fruit juice? So how do we solve this problem? Okay, let me pull up the camera. Okay, so I'll just write the reaction equation. So now, let's say we had 10 cups of juice and an infinite amount of rum. How much punch could we make? So consider the first case. If we have 10 cups of juice and an unlimited amount of rum. So we can make 3 cups of punch per 2 cups of juice. So we can put it in our conversion factor. Right, this is equal to 1. And then this cancels out. Can someone do this example for me? So what about, let's say we have 10 cups of rum and an unlimited amount of juice. Great, so divide by 1. Then we pick the smaller number. So that means we will be able to make 15 cups of punch, right? So now if we make this 15 cups of punch, we will consume 10 cups of juice, but how much punch will we, how much rum will we use? Great, 5. So that means we will have 5 cups of rum left over. Okay, so now just imagine this, except instead of talking about cups of juice, we're going to talk about moles of substance. Okay, we're going to talk about moles of compound. Okay, so let's just do this one problem. So how much ZnCl2 can be produced from the reaction of 2 moles of zinc and 3 moles of HCl? And what is the limiting reagent? So can we do this problem, please? So let's see. So our reaction is right? Okay. So we have 2 moles of zinc. So then you can see that zinc is in a 1-to-1 ratio. So if we had an infinite amount of hydrochloric acid, then we would be able to make 2 moles of zinc chloride. Now, we have 3 moles of hydrochloric acid. What if we had 3 moles of hydrochloric acid and an infinite amount of zinc? Since these are in a 2-to-1 ratio, we would be able to form 1.5 moles of ZnCl2. So we pick the smaller number, which is this. And then this means that all of our HCl will be consumed. So HCl is the limiting reagent. Do you have any questions? Or is anyone confused? If no one, okay. Does anyone have any questions about any of the topics in the lecture? If not, then I think that's the end of the lecture, and we don't have any time left. But what I want you to do is so what I want you to do is for today's homework, just go up to follow-ups, go to the presentation folder, and then do the lesson 4 practice. Actually, I can just move this into the homework folder.